A pair of fair six-sided dice is rolled n times. What is the least value of n such that the probability that the sum of the numbers face up on a roll equals 7 at least once is greater than 1/2? But let's see what happens in one roll of this pair. The probability that the sum is equal to 7 is 1/6 because there are 36 possible outcomes. And among these, there are 6 outcomes which gives us sum equals 7. 6 desired outcomes. And those are 1, 6, 2, 5, 3, 4, etc. up to 6, 1. Another way to see this is no matter what the first die roll is, there's 1/6 chance of the second one being so that the sum is equal to 7. So for example, if the first one is 3, there's one possibility for the second one to make it a sum of 7. Or 6, the second one has to be 1, the first one is 1, the second one has to be 6, etc. So no matter what you have for the first die, the second one is fixed if you want the sum to be equal to 7. Okay, so the probability of the sum equals 7 is 1/6. Hence, the probability that the sum is not equal to 7 is the remaining 5/6. Okay, so let's roll the pair n times now. Now what we want is the probability that the sum is equal to 7 at least once. So the sum is 7 at least once. And we want this probability to be greater than 1/2. Now this is harder to grasp, to calculate directly, because the sum, we don't know which one is 7. We don't know how many of these rolls are 7. There are many possibilities, but the opposite is easier. So if we look at the opposite, that the sum is not equal to 7 in all the rolls. And since this is the opposite, we want this to be at most 1/2. Now, to have the sum not equal to 7 in any roll, we want the sum to be not equal to 7 in the first roll. That probability is 5/6. And we want the same thing to happen in the second roll, third roll, etc. in all n rolls. And we want this to be at most 1/2. And this is because they are independent, right? If the sum is not equal to 7 in the first roll, the chance for it not to be 7 in the second roll is still 5/6. Okay, so let's see what this is for various values of n. When n equals 1, 5/6 is bigger than 1/2, so not good enough yet. When n equals 2, we have 5/6 square, which is 25/36, and that's also bigger than 1/2. For n equals 3, we have 5/6 cube. It's 125 over 216. It's still bigger than 1/2. Not there yet. And let's see what happens when n equals 4. 5/6 to the 4th power is 625 over 6 to the 4, which is 1296. And that is finally less than or equal, let's see, less than 1296. It's less, the ratio is less than 1/2 because 625 is less than 648. All right, so n equals 4 is the smallest value of n such that the desired probability in the original problem is greater than 1/2. And the answer is C.